Alright, now we're going to do some half angles. So the part A, we're going to do the sine, part B, the cosine, and part C, the tangent. So let's just do one at a time. And first of all, let's pretty much use our given information and calculate everything we'll need to know ahead of time. So first of all, they tell us that the secant of alpha is negative 13 over 12. What's the reciprocal of the secant of alpha? If we know the secant of alpha is this, what is the cosine of alpha? What's the cosine of alpha? The reciprocal, so right, so negative, and then we put 12 over 13. Now let's kind of get a sketch of this. Oh, what quadrant did they tell us it's going to be in? Quadrant 2. Alright, so cosine, this is going to be your x value. So first of all, out of the 12 and the 13, and this is your r value, so the 13 is here, which one gets the negative sign? If I was even confused, yeah, right. So make sure that you do that. So we're going to solve for our missing side. You can use Pythagorean theorem or your formulas that we've used previously. So I'll give you a minute to do that. Just your a squared plus b squared equals c squared, and we will get 5. Okay, so first of all, let me just back up for a minute and say why we changed this from secant of alpha to cosine. We could have filled that in, but let me scroll back over to my formula sheet. This is what I'm working with. And for my half angles, I want you to pay attention. Here's my sine alpha over 2, cosine alpha over 2, and tangent alpha over 2. I want you to look at each of these formulas and tell me what particular trig functions do we use. Cosine, right, for the most part. Tangent, this one has 2 different ways to work this one. So this one, or you can use this one, or you can use this one. But do you see, with me consistently, this one, to evaluate it, you need cosine alpha. This one, you would need cosine alpha. And for tangent, if we use this one, we need cosine alpha. So it would have been a good idea to mention that prior to just jumping right in and doing it. But I'm familiar with it, so it didn't catch my attention. So anyway, we noticed that prior to, all of the half angle formulas require us to know cosine. So we go ahead and we figure out cosine. We get our information here, and just in case we need any of our other values. And now we're going to go ahead and write our part A. So let's do sine. So this is part A. So sine alpha over 2 is equal to plus or minus the square root 1 minus cosine alpha divided by 2. Okay, let's plug this in. So we're going to do 1, that's a big one, 1 minus, so what is cosine alpha? Negative 12 over 13. Then divide by 2. So, alright, we're going to get plus or minus. Get a common denominator over here, which would make this one 13 over 13, right? So 13 minus a negative 12 would be 13 plus 12, would give us 25 over 13 over 2. Okay, to simplify the fraction underneath here, you can multiply by 1/2. Okay, we're showing all the steps here, so. And that's just going to give us 25 over 26. Can we evaluate the square root of 25? What's the square root of 25? 5, but what about the square root of 26? No, so we need to leave it as square root of 26, but we don't want to leave, we want to rationalize our denominator, basically. So let's do one more step and multiply by the square root of 26 just to simplify this expression even further. So it's going to be 5 square root of 26 over 26. Okay, now this is plus or minus. What do you think about this? What is the sign of our particular angle if we know it's in quadrant 2? Remember our all students take calculus? What sign will that get? The sign of alpha is positive in quadrant 2, so this is positive. Good. All right, next we're going to do cosine of alpha over 2. Using that same information, part B, let's cosine of alpha divided by 2, plus or minus 1 plus cosine alpha. Okay, so that's our formula. And our first substitution is going to be 1 plus cosine alpha right there. We're going to put negative 12 over 13 in. Okay, get a common denominator and simplify. We will get 1 over the square root of 26. So simplify just like we did previously. Okay, I may combine those two steps right there, but so now let's actually, what is the square root of 1? 1, good. And what is the square root of 26? It's just going to be the square root of 26. And we want to rationalize our denominator here. So right here, just a lot of algebraic simplification. Square root of 26 over 26. Now, what is the cosine value in our quadrant 2? Well, cosine's only positive here and here, so that means it's negative everywhere else. So we were going to say that this one will get a negative. Good. And then let's do one more, which is C is going to be our tangent of alpha divided by 2. Let's see how we are on time. Plus or minus. We're going to use that first formula, so it's 1 minus cosine alpha. 1 minus 1 plus. Okay, 1 minus cosine alpha, if I look back at my previous page, 1 minus cosine alpha, when I simplified it, it was going to be that 25 over 13. So I could say square root of 25 over 13. Or I can just leave this over the entire thing. And then go back and look at our 1 plus cosine alpha. 1 plus cosine alpha, just when we simplified our numerator, what did we get? Yeah, it was just going to be 1 over 13 right here. Which that's the step I skipped right there, because this would be 13 over 13. 13 minus 12 would be 1 over 13. So we have those values right there, and then now we want to simplify this a little further, so multiply by the reciprocal. These 13s will cancel, and we're going to be left with the square root of 25 over 1, which is just the square root of 25. And don't let me forget that plus or minus. What is the square root of 25? It's 5, but now let's determine if it's going to be positive or negative. So we're evaluating the tangent of theta, and we are right here. What do you think? Negative. Good. There's lots of different ways to work this. Don't let this confuse you when I skip some steps just using previous calculations. You can start over and just do it and calculate it. You'll get the same thing.